twisted pair cabling is a type of wiring in which two conductors of a single circuit are twisted together for the purposes of cancelling out electromagnetic interference from external sources, for instance, electromagnetic radiation from unshielded twisted pair cables, and crosstalk between neighboring pairs. It was invented by Alexander Graham Bell. Explanation: in balanced pair operation, the two wires carry equal and opposite signals, and the destination detects the difference between the two. This is known as differential mode transmission. Noise sources introduce signals into the wires by coupling of electromagnetic fields and tend to couple to both wires equally. The noise thus produces a common mode signal which is cancelled at the receiver when the difference signal is taken. This method starts to fail when the noise source is close to the signal wires. The closer wire will couple with the noise more strongly, and the common mode rejection of the receiver will fail to eliminate it. This problem is especially apparent in telecommunication cables, where pairs in the same cable lie next to each other for many miles. One pair can induce crosstalk in another, and it is additive along the length of the cable. Twisting the pairs counters this effect, as on each half twist the wire nearest to the noise source is exchanged, providing the interfering source remains uniform, or nearly so, over the distance of a single twist. The induced noise will remain common mode. Differential signaling also reduces electromagnetic radiation from the cable, along with the associated attenuation, allowing for greater distance between exchanges. The twist rate makes up part of the specification for a given type of cable. When nearby pairs have equal twist rates, the same conductors of the different pairs may repeatedly lie next to each other, partially undoing the benefits of differential mode. For this reason, it is commonly specified that, at least for cables containing small numbers of pairs, the twist rates must differ. In contrast to shielded, a foil twisted pair (UTP) cable is not surrounded by any shielding. UTP is the primary wire type for telephone usage and is very common for computer networking, especially as patch cables are temporary network connections due to the high flexibility of the cables. History: the earliest telephones used telegraph lines, or open-wire single-wire earth-return circuits. In the 1880s, electric trams were installed in many cities, which induced noise into these circuits. Lawsuits being unavailing, the telephone companies converted to balanced circuits, which had the incidental benefit of reducing attenuation, hence increasing range. As electrical power distribution became more commonplace, this measure proved inadequate. Two wires, strung on either side of crossbars on utility poles, shared the route with electrical power lines. Within a few years, the growing use of electricity again brought an increase of interference. So engineers devised a method called wire transposition to cancel out the interference. In wire transposition, the wires exchange position once every several poles. In this way, the two wires would receive similar EMI from power lines. This represented an early implementation of twisting, with a twist rate of about 4 twists per kilometer, or 6 per mile. Such open-wire balanced lines with periodic transpositions still survive today in some rural areas. Twisted pair cabling was invented by Alexander Graham Bell in 1881. By 1900, the entire American telephone line network was either twisted pair or open wire with transposition to guard against interference. Today, most of the millions of kilometers of twisted pairs in the world are outdoor landlines, owned by telephone companies, used for voice service, and only handled or even seen by telephone workers. Unshielded twisted pair UTP cables are found in many Ethernet networks and telephone systems. For indoor telephone applications, UTP is often grouped into sets of 25 pairs according to a standard 25-pair color code originally developed by IT and AMP-T Corporation. A typical subset of these colors shows up in most UTP cables. The cables are typically made with copper wires measured at 22 or 24 American wire gauge, with the colored insulation typically made from an insulator such as polyethylene or FEP and the total package covered in a polyethylene jacket. For urban outdoor telephone cables containing hundreds of thousands of pairs, the cable is divided into smaller but identical bundles. Each bundle consists of twisted pairs that have different twist rates. The bundles are in turn twisted together to make up the cable. Pairs having the same twist rate within the cable can still experience some degree of crosstalk. Wire pairs are selected carefully to minimize crosstalk within a large cable. UTP cable is also the most common cable used in computer networking. Modern Ethernet, the most common data networking standard, can use UTP cables. Twisted pair cabling is often used in data networks for short and medium-length connections because of its relatively lower costs compared to optical fiber and coaxial cable. UTP is also finding increasing use in video applications, primarily in security cameras. Many cameras include a UTP output with screw terminals. UTP cable bandwidth has improved to match the baseband of television signals. As UTP is a balanced transmission line, a balun is needed to connect two unbalanced equipment. For example, any using BNC connectors and designed for coaxial cable. Cable shielding. Twisted pair cables are often shielded in an attempt to prevent electromagnetic interference. Shielding provides an electrically conductive barrier to attenuate electromagnetic waves external to the shield, and provides a conduction path by which induced currents can be circulated and returned to the source via ground reference connection. This shielding can be applied to individual pairs or quads, or to the collection of pairs. Individual pairs are foiled, while overall cable may use braided screen, foil, or braiding with foil. When shielding is applied to the collection of pairs, this is usually referred to as screening, but different vendors and authors used screening, shielding, and SDP inconsistently to denote various shielded cable types. ISO IEC 11801-2002 attempts to internationally standardize the various designations for shielded cables by using combinations of three letters, U for unshielded, S for braided shielding, and F for foiled shielding, to explicitly indicate the type of screen for overall cable protection and for individual pairs or quads, using a two-part abbreviation in the form of XXDP. Shielded Cat5e, Cat6/6A, and Cat8/8.1 cables typically have FUTP construction, while shielded Cat7/7A and Cat8.2 cables use SFDP construction. Because the shielding is made of metal, it may also serve as a ground. Usually a shielded twisted pair cable has a special grounding wire added called a drain wire, which is electrically connected to the shield or screen. The drain wire simplifies connection to ground at the connectors. Common shield construction types used include individual shielding with aluminum foil for each twisted pair or quad. Common names: pair in metal foil, shielded twisted pair, screen twisted pair. This type of shielding protects cable from external EMI entering or exiting the cable and also protects neighboring pairs from crosstalk. Overall or shield overall foil, braided shield or braiding with foil across all of the pairs within the 100 ohm twisted pair cable. Common names: foil twisted pair, shielded twisted pair, screen twisted pair. This type of shielding helps prevent HEMI from entering or exiting the cable. Individual and overall or shield: individual shielding using foil between the twisted pair sets, and also an outer foil and or braided shielding. Common names: fully shielded twisted pair, screened foil twisted pair, shielded foil twisted pair, screen shielded twisted pair, shielded screen twisted pair. This type of shielding helps prevent HEMI from entering or exiting the cable and also protects neighboring pairs from crosstalk. An early example of shielded twisted pair is IBM SDPA, which was a 2-pair 150 ohms FTP cable defined in 1985 by the IBM cabling system specifications, and used with token ring or FDDI networks. The code before the slash designates the shielding for the cable itself, while the code after the slash determines the shielding for the individual pairs. U equals unshielded, F equals foil shielding, S equals braided shielding, TP equals twisted pair, TQ equals twisted pair. Individual shielding in quads. Common types: solid core cable versus stranded cable. A solid core cable uses one solid wire per conductor, and in a 4-pair cable there would be a total of 8 solid wires. Stranded conductor uses multiple wires wrapped around each other in each conductor, and in a 4-pair with 7 strands per conductor cable, there would be a total of 56 wires. Solid core cable is intended for permanently installed runs. It is less flexible than stranded cable and is more prone to failure if repeatedly flexed. Stranded cable is used for fly leads at patch panel and for connections from wall ports to end devices, as it resists cracking of the conductors. Connectors need to be designed differently for solid core than for stranded. Use of a connector with the wrong cable type is likely to lead to unreliable cabling. Plugs designed for solid and stranded core are readily available, and some vendors even offer plugs designed for use with both types. The punch-down blocks on patch panel and wall port jacks are designed for use with solid core cable. Advantages: electrical noise going into or coming from the cable can be prevented. Crosstalk is minimized. Cheapest form of cable available for networking purposes. Easier to handle and install. Disadvantages: deformation. Twisted pairs' susceptibility to electromagnetic interference greatly depends on the pair twisting schemes staying intact during the installation. As a result, twisted pair cables usually have stringent requirements for maximum pulling tension as well as minimum bend radius. This fragility of twisted pair cables makes the installation practices an important part of ensuring the cable's performance. Delay skew. Different pairs within the cable have different delays due to different twist rates used to minimize crosstalk between the pairs. This can degrade image quality when multiple pairs are used to carry components of a video signal. Low skew cable is available to mitigate this problem. Imbalance. Differences between the two wires in a pair can cause coupling between the common mode and the differential mode. Differential to common mode conversion produces common mode currents that can cause external interference and can produce common mode signals in other pairs. Common mode to differential mode conversion can produce differential mode signals from common mode interference from other pairs or external sources. Imbalance can be caused by asymmetry between the two conductors of the pair from each other and in relationship to other wires and the shield. Some sources of asymmetry are differences in conductor diameter and insulation thickness. In telephone jargon, the common mode is called longitudinal and the differential mode is called metallic. Less common variants. Loaded twisted pair. A twisted pair that has intentionally added inductance, a formerly common practice on telecommunication lines. The added inductors are known as load coils and reduce attenuation for voice band frequencies but increase it on higher frequencies. Load coils reduce distortion in voice band on very long lines. In this context, a line without load coils is referred to as an unloaded line. Bonded twisted pair. A twisted pair variant in which the pairs are individually bonded to increase robustness of the cable. Pioneered by Belden, it means the electrical specifications of the cable are maintained despite rough handling. Twisted ribboned cable. A variant of standard ribboned cable in which adjacent pairs of conductors are bonded and twisted together. The twisted pairs are then lightly bonded to each other in a ribbon format. Periodically along the ribbon there are short sections with no twisting to enable connectors and PCB headers to be terminated using the usual ribbon cable IDC techniques.